Hello viewers, my name is Dr. Ajay, Associate Professor, Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. So today we are going to discuss about the topic on problems of ground wave propagation. This topic is related to the course Antennas, Waves and Propagation. So what is a ground wave propagation? So when the waves are going to transmit over the surface of the earth, we call it as a ground wave propagation. So whenever we are going to transmit the electromagnetic waves on the surface of the earth, the waves are attenuated by the surface of the earth. So how much the waves are attenuated, it is given by the expression A is equal to 2 plus 0.3 p by 2 plus p plus 0.6 p square. So the how much amount of attenuation is taken by the earth, it is given by the symbol capital A, that is equal to 2 plus 0.3 p by 2 plus p plus 0.6 p square. So here p is just any auxiliary variable. Is given by 0.582 into d into f square by sigma milliseconds per meter. So to find out to determine the attenuation value, to determine the electric field strength reached at the receiving point, so we need to have an idea on some of the formulae in the ground wave propagation. So first, before going into the formula, we need to know whether the transmitting antenna is vertically polarized or horizontally polarized. So in ground wave propagation, always the antenna is vertically polarized. So when the antenna is vertically polarized, then there will be less attenuation by the earth. But when the antenna is horizontally polarized, there will be more attenuation by the earth. Hence, vertically polarized antennas are preferable than horizontally polarized antennas in the ground wave propagation. Now let us find out the value of P in vertically polarized wave. Suppose if the antenna is vertically polarized like this. This is vertical antenna, and if we place the antenna like this, this is horizontal antenna. This is horizontal antenna. So P is equal to pi by x g by lambda. So P and B are any auxiliary variables, and B is written as tan inverse of epsilon r plus 1 by x. Epsilon r represents the relative permittivity of the earth. So the permittivity of the earth varies from area to area, and x is the conductivity is given by 1.8 into 10 power 12 by f sigma. So sigma represents the conductivity, and here x, b and p, these are three represent three auxiliary variables to determine the value of A here. So A depends upon three auxiliary variables, that is p, b and x. So whether if the antenna is vertically polarized, we need to find out by using the formula P is equal to pi by x d by lambda cos b. Similarly, if the wave is the antenna is horizontally polarized, we should use the formula P is equal to pi d x by lambda into cos b, and b is equal to 180 minus b1, and b1 is equal to tan inverse of epsilon r minus 1 by x. So these are the formulae commonly used in ground wave propagation to find out the amount of field strength reached towards the receiving antenna. So based upon this formula, we shall do the problem. That is a police radio transmitter operating at a frequency of 1.69 MHz is required to provide a ground wave having a strength of 0.5 millivolts per meter at a distance of 16 kilometers. The transmitting antenna with efficiency of 50% produces a radiating field proportional to cos theta. The ground wave having a sigma is equal to 5 into 10 power minus 3 ohms per meter, and epsilon r is equal to 15. Calculate the power transmitted here. So here all the data is given in the whatever the required data, it is given in the problem here. So we need to calculate first what is the amount of field strength reached to the receiver. So based upon the value of the electric field strength, we are going to find out what is the amount of power transmitted by the transmitting antenna. So here we are getting we are having some data given, that is Eg. We know that Eg is equal to, it is given as 0.5 into 10 power minus 3. It is given as 0.5 into 10 power minus 3, and the frequency it is given as 1.69 megahertz here. And d, the distance of propagation, it is given as 16 kilometers. So we can write as in the SI units 16 into 10 power 3 here. So similarly, frequency can be written as 1.69 into 10 power 6 here. And the efficiency is given as 50%. This is equal to 50 by 100. This is equal to 1 by 2. And epsilon r is equal to 15. It is given in the problem here. And here this is the data given as per the problem. So based upon the data, so we need to find out the value of the electric field strength first. So here the frequency is 1.69 10 power 6. So we are going to find out the lambda value. So lambda is equal to C by F. C is equal to 3 into 10 power 8. The frequency is 1.69 into 10 power 6. So you will get 177.5479 meters here. So lambda is equal to 177.5479 meters here. So here the antenna is vertically polarized here as given in the problem. The antenna is said to be the vertically polarized antenna. Why? Because it is directly proportional to cos theta. So why? Because the radiation pattern it is given as it is proportional to cos theta. So if you take cos theta, theta is equal to 0. What is cos theta? If for cos theta is equal to 0, cos 0 is equal to 1 here. So here the radiation pattern is maximum along 0 degrees. So theta is equal to 0. Similarly, in 180. So we get this type of radiation pattern when the antenna is vertical here. We achieve this type of radiation pattern when the antenna is vertical here. So when the antenna is vertical, you will get radiation pattern like this. So for this radiation pattern, the function we can assume is cos theta. Why? Because when theta is equal to 0 and theta is equal to 180, the radiation pattern will be maximum along the direction of 0 and 180 here. It is perpendicular. So hence, as the radiation pattern is a maximum proportional to the cos theta, so we are assuming the antenna is vertically polarized. Hence, we are going to consider only the formula of vertically polarized antenna. So just now we have considered, we have seen the formula of the vertically polarized antenna, and we are going to make use of those formulae for this problem. So B is equal to, for vertically polarized antenna, tan inverse of epsilon r plus 1 by x here. But what is the x value here? 1.8 into 10 power 4 sigma by f megahertz here. So from this value, you are going to find out the value of here sigma x value 1.8 into 10 power 4 by the value of f is given as 1.69 into 10 power 6 into the value of sigma is 5 into 10 power minus 3. The conductivity of the earth is given as 5 into 10 power minus 3, 5 millivolts. So this, the value of x is 53.2 mho per meter here. If you simplify this, you will get the value of x as 53.2 mho per centimeter. And similarly, you are going to find out the value of b. So b is equal to tan inverse of epsilon r plus 1 by x. So tan inverse of the value of epsilon r, it is given as 15 plus 1 by 53.2. So you will get b is equal to approximately 16.72 degrees here. You will get approximately b is equal to 16.72 degrees here. And we are going to find out another auxiliary variable for a vertically polarized antenna. P is equal to pi by x d by lambda cos b here. So here pi by, we got the x value as 53.2. The value of d is 16 into 10 power 3. The value of lambda is 177.5. The value of b is cos 16.72. So if we simplify this mathematical expression, you will get 5.0914. Now we need to find out the value of a here based upon the value of p. Why? Because p is interrelated to the value of a. A stands for attenuation. So 2 plus 0.3p by 2 plus p plus 0.6 p square here. So 2 plus 0.3 into 5.09 divided by 2 plus 5.09 plus 0.6 into 5.09 whole square here. So if you simplify this, you will get 0.155 here. So if you simplify this, you will get the value of a as 0.155 here. Now here we are going to find out the value of Eg now. So we know that Eg is equal to E naught A by D. So we have determined the value of A. Here, what is the value of A? Attenuation is equal to 0.155. So let us substitute this value of A in the Eg value, in the Eg equation. But we know that E naught is equal to 300 root PR into A by D. So here E naught is equal to 300 root PR. 300 root PR. This is equal to Eg here. So if you substitute here PR, simplify, PR is equal to Eg D by 300 A whole square you will get. So what is the value of Eg from the problem? It is given as 0.5 into 10 power minus 3. The value of D is 16 into 10 power 3 whole divided by 300 into the value of attenuation we got here as 0.155 here. So we will get as 0.155 whole square here. So 0.5 into 10 power minus 3 into 16 into 10 power 3 by 300 into 0.155 whole square. So if you simplify this, you will get the value as 0.03 watts here. So PR is equal to 0.03 watts. So we are going to derive the expression, the ground wave field strength. The ground wave field strength is given by Eg is equal to E naught A by D, where E naught is the electric field strength at a unit distance from the transmitting antenna, and A stands for the attenuation of the earth, and D is the distance of propagation. And there is a relationship between the electric field strength from the transmitting antenna and also the power radiated by the transmitting antenna, which is denoted as E naught is equal to 300 root PR here. So PR stands for power received by the receiving antenna. So from this equation, we got the power received is equal to 0.03 watts here. So here, as per the data given, the efficiency of the antenna is given as is equal to 50% here. So 50% means 50 by 100 is equal to 1 by 2. So what is the antenna efficiency definition? According to the definition of antenna efficiency, the power received to the power transmitted, the ratio, we call it as antenna efficiency. So to determine the antenna efficiency, the ratios of the power received and the ratios of the power transmitted must be known here. So here PR by PT. Here efficiency is equal to 1 by 2 here. So 1 by 2 is equal to, what is the amount of PR we got just now? It is 0.03 here. So 0.03 power. So from this equation, PT is equal to 0.03 into 2 here. So this is equal to 0.06 watts here. So PT is equal to 0.06 watts. So this is the amount of power transmitted between the two stations by ground wave propagation, 0.06 watts. So we are propagating 0.06 watts whose efficiency is 50%, and hence the transmitting antenna, the power received is only 0.03 watts here. So the power received to the antenna is 0.03 watts here. So let us see the problem, basic problem. So how we have seen. So this is the value of lambda. Lambda is equal to C by F. So 177.5479 we are getting. And this is the vertically polarized antenna. So B is equal to tan inverse of epsilon r plus 1 by x. And x equal to 1.8 in 10 power 4 by F megahertz. Let us substitute the values of the given data. Sigma is given as 5 into 10 power minus 3. So this is equal to 53.2544 mho per meter here. From this value, we are going to find out the value of B, tan inverse of epsilon r plus 1 by x. So this is tan inverse of epsilon r plus 1 by x, the formula. So we have the x value is substituted here in this formula here. And 15 epsilon r is given as 15 in the given data. So 16 by 53 you will get 16.72 degrees. And as the vertically polarized antenna, P is given by the auxiliary variable, P is given by pi by x d by lambda cos B here. And x value is 53.25, lambda we have determined from C by F as 177.5. And the d value is 16 into 10 power 3 cos 16.72. So So this is equal to 5.0914. So A is equal to the attenuation by the earth is given by the formula 2 plus 0.3 P by 2 plus P plus 0.6 P square here. So substitute the value of P here in this equation here. We'll get the value of A as 0.155. And similarly, we are going to find out the amount of power received based upon the ground wave propagation. It is given by the expression Eg is equal to E naught A by D. So 300 root PR by D here. So 300 into A by D is equal to root PR here. So from this equation, if you simplify here, you will get the value of PR as Eg D by 300 A whole square. So just simplify the values here as per the data given. So D is the distance is 16 10 power 3. And the attenuation we got the value as 0.155. So it is 0.03 watts. As we know that the efficiency is given as 50%. 50% means it is 1 by 2 here. So 1 by 2 is equal to PR by PT. So the power transmitted is 2 into 0.03 is equal to 0.06 watts here. So the power transmitted by the transmitting current is taken as 0.06 watts here. So like this we need to find out the amount of power transmitted or amount of power received by receiving antenna based upon the polarization of the antenna. So we need to know whether the antenna is vertically polarized or horizontally polarized, and appropriately those formula must be used to determine the value of field received by the receiving antenna. So these problems, more problems can be you can do by referring the textbook Antennas and Wave Propagation by U.A. Bakshi, and also K.D. Prasad by Antennas, Waves and Propagation. And for more problems, you can also refer the Balanis textbook, also John D. Cross. So more problems on ground wave propagation, you can refer the textbooks Balanis or John D. Cross or Bakshi or K.D. Prasad. So let us close the session today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.